Hello everyone, welcome to this course titled Optimal Control Systems. I am your instructor for this course. My name is Dwaipayan Mukherjee. I am a faculty member at the Department of Electrical Engineering at IIT Bombay, and I am a part of the group that is Control and Computing. So this course on optimal control systems has been a graduate level course in our department and within our specialization, particularly meant for postgraduate students, that is masters as well as PhD students. However, undergrad students routinely attend this course as well as part of their electives. So what is the main purpose of this course? What do we aim to achieve through this course? Okay. This is a very significant course in the sense that there is a lot of history that is also involved with this course. This is not just a course on optimization, neither is this a course on control systems alone. So a desirable background would be to have some familiarity with control systems as well as perhaps some familiarity with linear algebra and optimization. However, none of those are hardcore prerequisites because whatever knowledge you'll be required will be covered during this course. Okay, so there are no hard prerequisites, but as I said, some fleeting acquaintance with control systems is desirable nonetheless. People from mathematics background might also find this course interesting because the first part of this course will be dedicated towards calculus of variations. So we will start off with finite dimensional optimization problems, then we will move into calculus of variations. And during this journey, we will go through some of the fascinating problems over the last 400 years, and we will walk along the path along which some of the greatest mathematical minds in the last 4 centuries have walked. They include the Bernoullis, Isaac Newton, and we will also discover that at the heart of most of these natural phenomena that we see around us is some sort of an optimization. Yeah? The celebrated principle of least action is a manifestation of such optimization. We will sort of get a glimpse into the mind of nature, as it were, as we shall see how light, the reflection or refraction of light that is also governed by some sort of an optimality at the heart of it. Then we shall look into the brachistochrone problem, a very, very celebrated problem which was apparently, as the legend goes, thrown in as a challenge by Bernoulli to his contemporaries, and which was famously solved by Isaac Newton in an anonymous manner. We will go into this details of this brachistochrone problem. We will view this brachistochrone problem from multiple perspectives. Initially through a geometric perspective, then we shall go into it from a calculus of variations perspective, and finally, as we delve into the heart of this course, which is essentially Pontryagin's maximum principle, we will look at this brachistochrone problem once again through the lens of this maximum principle as an optimal control problem, right? And it will be very instructive to get these multiple perspectives on this hold us back and how the application of the maximum principle frees us from those shackles and allows us to solve such optimal control problems within a much more general framework. This will in turn motivate us to dig deeper into a detailed proof of the maximum principle, because this is not just for pedagogy alone that we shall endeavor to understand this proof. We shall also see that a detailed understanding of the maximum principle and its proof will allow us to apply the maximum principle to a wide variety of settings. Now, there's a reason why it's called a maximum principle and not a theorem, because it is actually something greater than a theorem, if I were to put it that way. It allows you to generate theorems of your own subject to the setting in which you are applying it, right? So that is the maximum principle in its full glory, and we shall aim to reveal that to you during this course. Towards the end of this course, towards the latter half of this course, we shall also delve into an alternate approach towards optimal control, which was developing almost simultaneously around the other side of the Iron Curtain in the United States in the form of dynamic programming. And we shall try to see the similarities between them, but also talk about the differences between these two approaches. Finally, we will wind up the course with the celebrated linear quadratic regulator. We shall see Again, multiple approaches towards solving the linear quadratic regulator problem, both within the finite horizon as well as the infinite horizon. One of the things that you would particularly notice as you progress through this course is that we will not compromise with the level of rigor at any stage. However, there will be certain results that will be considered well beyond the scope of this course, certain results that stem from an understanding of topology, which will be beyond, whose proofs at least will be beyond the precincts of this course. Subject to the availability of time, right at the end, we might cover one or two applications as well. But even if we do not manage to go very deep into those applications, rest assured, with the kind of knowledge that you shall be equipped with by the end of this course, you will be able to apply the tools that you have learnt during this course to your particular problem domain. So this is not an applied optimal control course as many courses are dubbed. Rather, this is a journey into the heart of optimal control with some beautiful nuggets of history strewn randomly at different relevant places. So I hope that you will enjoy this journey with me as much as I will also surely enjoy talking about the development of probably one of the most non-trivial subjects that we teach our graduate students who are specializing in the control and computing group. With that, I hope that you will join in good numbers and you will find the content of this course motivating. And if you wish to go into things like model predictive control or into other applications of optimization even, or dynamic programming, whichever is of your interest, you will find something or the other in this course that will be extremely useful to you. I hope you'll find this enjoyable and wish you happy learning. Thank you.